reality capture really enables us to take a step back and completely reimagine how we execute work. This is happening on a weekly basis all across the industry, where customers have to shut units down to perform maintenance, to replace components that are worn out. One day of downtime can be lost production, anywhere from hundreds of thousands of dollars a day to millions of dollars a day. And so being able to leverage reality capture to reduce those durations significantly, that's where the value's at. That's big money. Take a compressor replacement where historically that may have taken you 10 days and now it takes you 3. This is really the first step. We need to get a true replica of what's in the field, what's in the unit, so that we can base everything else that we do off of that. Inside turbo machinery, parts are fabricated to sub-thousandth of an inch accuracy. So we need precision reality capture, and that's what you see here. When we get in the middle of a turnaround, we can scan the inside of a compressor casing and virtually overlay that rotor into the unit to evaluate internal clearances without having to physically install the components. And we know that everything's going to fit. There's no additional measurements. We leverage that data to perform finite element analysis to optimize the design so that we're increasing the longevity, the reliability, safety of the machine while it's in operation, with the end goal of how do we shorten these durations? How do we get this right the very first time when we go out and execute this work? 60% duration reduction here. We've seen 75, 80%. Reality capture opens the door for innovative solutions such as this. And at the end of the day, this is the proof that the value's there. All right, guys. So my name is Craig Simpson. I'm Vice President of Technology for a company called Rotating Machinery Services, or RMS. Prior to RMS, I was actually also with ExxonMobil for 10 years. During that time, I held various turnaround leadership roles, supported project and maintenance work as well. And one of the primary objectives that I had when I was there was, how do we improve turnaround competitiveness? Or how do we reduce the duration associated with downtimes, with maintenance events? And one of the ways that we found that we could do that is leveraging reality capture, both at the macro level and the micro level. And so we'll get into that. But first of all, during that time, I met a guy named Tony Francis. Tony is now the Director of Technology Development for RMS. And Tony actually founded a company called Origin Metrology Group back in 2013 and was CEO of Origin Metrology until RMS actually acquired that business earlier this year. Tony has over 22 years of metrology experience. RMS, just a little bit about the company, we're a collaboration of companies. So we're owned by private equity, and with private equity, as typical, we've gone and acquired numerous other companies that complement the core RMS business. So RMS at its core is an engineering company. We design and fabricate turbo machinery such as compressors and turbines, but we also service and upgrade our competitors' equipment as well through re-rates and various things by leveraging reality capture at the precision level. Over the past several years, RMS has grown significantly by acquiring major product lines from big players like GE, Dresser, Rand. We've acquired shop space from Mitsubishi, acquired a field service company. But really over the past year or two, RMS took a step back and said, hey, how do we truly differentiate ourselves from our competitors? How do we set ourselves apart from the rest of the industry? And the consensus was, we want to invest in technology. We want to invest in innovation. Hence, me coming on board in the Origin Metrology acquisition. I love Henry Ford's quotes, and this is one of my favorites. He said, if I'd asked people what they wanted, they would have said faster horses. And I think that's still so true across so many industries today. If you look out, and I know we all have similar stories in that, a lot of people are doing the same thing that we've been doing for the past 40 or 50 years, executing work the same way with only incremental improvements. But reality capture really enables us to take a step back and completely reimagine how we execute work. At RMS, what's that mean? So from the technology services that we offer really range, I like to break it down into 4 distinct categories. And the basis, the foundation for all of it is reality capture on the front end, both at the macro and the micro level. So that's whether we're laser scanning an entire facility with turbo machinery and auxiliary components, or we're at that precision level. We're capturing high fidelity, high accuracy data. That really enables everything else that you see on this list, such as dimensional analysis, engineered upgrades, advanced quality control. We'll talk a bit about virtual assembly, an innovative concept to performing maintenance on equipment. And then, we'll end by talking about how we don't want that data to just live in a silo. We don't want that to be one-time use data, but we want to extract maximum value from the data that we're capturing throughout the entire life cycle of an asset. So we'll get into some of the immersive training and digital procedures. And so this just walks through, the various topics that we'll go through. At the end of this, I'm gonna talk through an actual case study that we executed earlier this year to show, hey, this isn't just painting a pretty picture, but how does this add value to the end user at the end of the day? Significant value. And we'll talk through that. You'll notice a lot of animations throughout the presentation. Over there on the right-hand side, you see that's content that we captured, both macro, micro, reality capture, but then developed the content in collaboration with a company that we partner with known as Modestry. So you'll see some of that content scattered throughout. Okay, so again, regardless of what type of project that we're going to execute, we're really going to start with that reality capture at the macro level. Whether we're planning a maintenance event for a customer, whether we're collaborating with our engineering team on designing and fabricating a new piece of equipment, 3D modeling that piece of equipment. This is really the first step. We need to get a true replica of what's in the field, what's in the unit, so that we can base everything else that we do off of that. For those of you that are interested, that is Preview 3D. That's their platform where we've the platform of choice really for RMS, some of the highest quality in the industry. If you guys are interested in that, I know they're out here somewhere. I think they've got a booth on the second floor.
Yeah.
So once we've captured that data at the macro level, a lot of times we're going to use that, like I said, for 3D modeling purposes. So on the left-hand side, you'll see a laser scan of a centrifugal compressor in a facility. And in that example, we may be replacing that compressor, we may be overhauling that compressor, we may be building a training package for that particular machine, but that's how we're going to go and capture the outer shell. And so on the right-hand side, you see we've actually 3D modeled that compressor and ingested that back into a laser scan. So in this example, that's representing, we're replacing a compressor. We're scanning an existing unit, a competitor's piece of equipment, and we're designing a piece of equipment to drop back into that same footprint. We leverage the reality capture to design that piece of equipment, but then we also leverage reality capture to scan the new fabricated piece of equipment to not only validate the design, but actually validate what we've fabricated, make sure everything's going to fit up. I talk about turnarounds and maintenance events, and one thing I want to highlight is, specifically in the oil and gas industry, petrochemical industry, and many other industries out there, one day of downtime can be lost production, anywhere from hundreds of thousands of dollars a day to millions of dollars a day. And so, being able to leverage reality capture to reduce those durations significantly, that's where the value's at. That's big money, real dollars. So what I just showed you was just a piece of the puzzle, right? I mean, we go out there and we'll scan a unit, we get the shell, and that's great, but all of the work's happening inside that compressor. Inside turbo machinery, parts are fabricated to sub-thousandth of an inch accuracy, right? It's the tolerances there are super precise. And so even when we're building equipment, all of those components inside, the clearances are down to thousandths of an inch. So we need precision reality capture, and that's what you see here. So when we're inside the machines, or when we're scanning the spare parts that we're going to build that machine with, we're going to leverage tools like this. So some of you may not be as familiar with the precision tools. This is a Leica AT960 laser tracker. We use some other technology as well, but primarily stick with that Leica tracker when we're capturing data in the field, precision data. Up in the top left-hand corner, that's a T-probe. So we're actually not scanning here. We're capturing point data. Any place that probe touches, we're getting precise XYZ coordinates. That top middle photo is actually data output. That was an example where we captured the critical geometry on a new gas turbine that had been fabricated. And then we were virtually overlaying that onto an existing gas turbine in a facility to validate that it was going to fit without any issues. When we need to capture more complex geometry with still that same level of precision, we're going to use something like what you see in that bottom video, which is the AS1 scanner. It also connects to that same laser tracker, and so all that data can be tied together. But you see in the bottom left photo, that's an example of precision data that's actually been scanned, in that 1 thou accuracy range. Okay, so now that we've captured the high precision data, what do we use it for? These are just some examples, right? So dimensional analysis is one big thing for our company, in that all these pieces and parts. We talked about the manufacturing tolerances, but that photo on the left is a centrifugal compressor rotor, where we're mapping out the critical geometry on that rotor for QC purposes, but we're also mapping it out so that when we get in the middle of a turnaround, we can scan the inside of a compressor casing and virtually overlay that rotor into the unit to evaluate internal clearances without having to physically install the components. And we'll get to why that's important. Top right photo is compressor casing, so upper and lower half, where the gas inside these machines is at high pressures, potentially toxic. And so historically, to make sure the upper and the lower half of a turbo machine sealed together required you to physically put those two halves together and do some intricate measurements. But with the precision technology, reality capture, you can go and we can scan that split line on top and bottom half, virtually assemble them together, look at highs and low points, and make adjustments without having to go and physically assemble components. Bottom right-hand photo is another really cool one. So this is a huge steam turbine rotor. In that, the customer, their unit shut down, unexpected. We go and we digitally map out that spare rotor prior to the actual unit being open. And once the unit's open, we go in, we pull all the old components out, and then we're able to scan all the internals and virtually overlay that spare rotor into the unit to align all of our internal components without ever physically installing that rotor. So that when we do install that rotor, we can do it with a single lift, and we know that everything's going to fit. There's no additional measurements. So that may not sound like much for those of you that aren't familiar with turbo machinery, but that when you can reduce a duration by 50%, 75%, because you're no longer having to take an iterative approach to maintenance by putting pieces and parts in, take measurements, pull them back out, make adjustments to them, and do that several times over and over again. That's the piece that reality capture really enables us to mitigate. The other piece of that is, with the precision reality capture come all the engineering capabilities, the things that we have to do to go and design new equipment and provide engineered upgrades. So not only are we scanning the facilities, the outer shell, the components, all the way down to, this is an axial compressor blade, single axial compressor blade. A single rotor may have hundreds of those blades installed on it. But we leverage that data to perform finite element analysis, to optimize the design, so that we're increasing the longevity, the reliability, safety of the machine while it's in operation. In the data capture, you guys know this, that enables us to go further with stress analysis, whether that be through FEA, CFD, et cetera. Okay, and so, as we've talked about the reality capture and how we leverage that to design new equipment, how we leverage it to provide engineered solutions, QC. But now let's get into the virtual assembly piece. And so this is really the innovative approach that Origin Metrology brought to the table with RMS, because this is unique to the industry, at least in the turbo machinery world. In this particular example, you see an axial compressor that's being overhauled. So axial compressor has to be taken apart. All the components are worn out inside. We have to replace those with new. Again, when that unit's out of operation, lost production for the customer. So we want to do everything that we can to shorten that duration. On the left-hand side, you see scanning an axial compressor rotor, with that precision reality capture, and we map out that geometry, and we have that going into the turnaround, such that when the turnaround happens, when we're inside the equipment, we pull out the old equipment, we virtually overlay that rotor inside, and as we're scanning inside the machine, we've already virtually positioned that rotor such that we can evaluate all of those internal clearances and make adjustments real time. So that's where a lot of the efficiency comes with the execution process. But it's not just tailored to providing an overhaul on the equipment. Also, just from an asset replacement standpoint, I hit on this at the beginning. But again, this is, we've captured that environment with an RTC, for instance, that compressor lives in, and now we want to replace that piece of equipment. A lot of times we'll bring the tracker out on the deck as well. We'll connect back into that same data, tie it all together, and then we'll take that precision scanner. We'll go around the machine and scan, pipe flanges, nozzles, base plate, feet, hold down bolt locations, et cetera, where we want that higher level of accuracy, of granularity. And then, we use that to model the new machine. So we're designing based off of that, but then we also scan the new machine once it's been fabricated before it ever gets into the unit. So that when we get to the customer location, before we ever install it, we know that it's going to fit. We know exactly where we need to install it to align it. You take a compressor replacement where historically that may have taken you 10 days and now it takes you 3. So again, it's minimizing discoverables, and it's looking for optimizations on the actual execution front. So the other piece is, we don't just stop at the machine itself. Obviously, when you're scanning out in the field, you've got that reality capture. You're also gathering data for the surrounding equipment. So this is just an example of piping that's going to connect up to a machine, towers, drums that are in the area. In this particular case, we were supporting a project where we were trying to install. The customer was trying to install new piping to go into a unit, and you guys have seen before where you overlay CAD data with scan data. Most folks are doing that, but taking it a step further in that all of the pipe spools that were prefabricated, using the precision scanner with that laser tracker to go out and scan those pipe spools, and then virtually overlay the actual design or the actual fabricated piping back into that scan to see how things are going to fit up prior to, once again, that unit coming down. So we can make adjustments and again minimize the discoverables during the downtime. Okay, and then finally, since we've captured all this data, both at the macro level, you see that over on the right-hand side, we're actually in the unit where we've scanned that unit, down to the micro level where we've got all the individual components that are scanned. We use that for 3D modeling, engineering, et cetera. We don't just want that to be a one-time use. Yeah, that was super valuable, but we want to take that a step further, and we leverage our partners at Modestry to basically build out a visual replica of the execution process. Customers want to use that for training purposes prior to turnarounds and maintenance events, once again, to get everybody on board so that we're all on the same page, speaking the same language, both from a contractor standpoint and a customer standpoint. With the end goal of how do we shorten these durations? How do we get this right the very first time when we go out and execute this work? The other reason that customers want to see this content is just from a knowledge retention standpoint. We all face the same issue with folks in the industry that are most experienced continue to retire, and we want to set up the next generation to jumpstart careers and to capture the knowledge that guys have that they've learned over the past 30 years in the industry. But we don't just stop at the 3D lessons. So there's all kind of other data that we want to tie this to as well. So maintenance manuals, drawings, QC documentation, historical notes, pictures. We want all that data to live together so that when the customer's planning for a maintenance event, when they're planning for a project, when they're executing the project, we want them to have all that information at their fingertips so they can dive into the 3D training, the data that we've captured, the content that we've developed, but they can also see all that other information along with it, and it's connected. And so that's what you see, with the iPad there on the right-hand side. You see you see a QC form there on the left side of the screen, all connected to that 3D data. Okay, and so again, why is all this important? We've talked about reducing, I keep saying it over and over, we talk about reducing durations associated with projects, with turnarounds. And so this is a specific use case that we chose to show you guys. But this is happening, on a weekly basis all across the industry where, customers have to shut units down to go into them, to perform maintenance, to replace components that are worn out. This is a centrifugal compressor that we overhauled. Historically, without virtual assembly, without the reality capture, without all this technology, that would have taken 12 days to execute. But the technology and the innovative approach here enabled us to execute that in 4 days. So how do we do that? And not going to go into super high level of detail or super detail here, but for those of you that don't know turbo machinery, but this is a spare rotor prior to a turnaround. So again, we're digitally mapping out the critical geometry of that rotor prior to the event, and that really enables us to start to build out all of those spare parts. Now that we have a digital replica of those components, we can precision locate those components, build them together, and take a more modular approach to maintenance. So that may not look like much to you guys, but that's not the historical or the traditional way that you would prepare for a maintenance event. All of that would be individual components, and you would be stick building that during the turnaround. But this technology or this approach, reality capture, really enables us to approach maintenance this way. During the turnaround, again, we're going to go pull out all the old components, clean everything up, take some reference measurements so that we know we can virtually overlay that those assembled components into position, optimize their running location, such that during the turnaround we're going to bring that rotor in as a single lift. This shows us capturing some of the critical geometry inside the machine. So what's happening here is we're using the laser tracker and the T-probe to actually map out some of the internal seals inside the compressor. Now, the seals that he's mapping out, you can see in the background that the actual spare rotor is virtually overlaid, virtually assembled into the compressor. And if that rotor were installed right here, the position where he's measuring, the clearance between that rotor and the labyrinth seal may be 10,000ths of an inch, right? You may have a tolerance of plus or minus 5, 6. So super critical clearances. But if you could see his computer screen that he's looking at, you would see that it's showing him the clearance with that rotor virtually installed at each position that he's touching along that labyrinth seal. So we know real time before we've ever physically installed the rotor what adjustments we need to make to that seal. and there may be 20, 30 seals inside that unit. And that's just one example of how we're leveraging virtual assembly inside of a turbo machine to make decisions and to make adjustments prior to ever physically installing the rotor. And then lastly, this is it, right? It's all to get to this point in that rotor now becomes a rotor assembly, becomes a modular assembly, such that we install that with a singular lift, and we're confident when we do that it's going to be right the first time. Now that was a journey to get here. This didn't happen overnight. This was working many years with Origin metrology to gain confidence in bucking the system and innovating and going away from traditional techniques. Again, historically, this was a stick-built approach. Rotor goes in, you have to take measurements, you have to pull it back out, make adjustments, put it back in, take more measurements, pull it back out, make more adjustments. And then you start building your seals and your bearings, and you have to take stuff to the machine shop and make adjustments. And that's where that duration just becomes extended when all of that's happening during the middle of a turnaround in a very stressful environment. So anyway, reality capture, again, just opens the door for innovative solutions such as this. And at the end of the day, this is the proof that the value's there, where you can take a downtime where historically on the top you see 12 days to execute at best, to where we're capturing all of that data ahead of time. We're precision aligning it and building it together to reduce that duration significantly. So 60% duration reduction here. We've seen 75, 80%. It's just another example of where reality capture, both from the macro level down to the micro level, really enables us to take a very innovative approach to changing the way we do things. So, thank you.